I've done modeling on it using different algorithms.
Okay.
So for the algorithm, so I got 95% for the training, but 77 for the testing.
Okay.
With another algorithm, I got 90% for the training and then 91% for the testing.
Okay.
So which of these two algorithms is the best?
Okay. Well, at a quick look at, our target is always to get better testing result, okay?
Yes.
So we go for the second algorithm that is giving you 91%. It's very rare to have such. You have to check that your model is correct, that you did not mistakenly use training set as testing set, you know? Once you do double checking to make sure that there's no mistake from your side, and then, because when you have 97%, the first one
was 95 training, but 77 for the
95% the training.
Yes. So, but the second one, I can only get 90% for the training.
Yeah, 90% for training, and then 91%. Yeah,
Yes.
this is a very excellent work. So it's very rare to have testing set better than training set, but this is our wish. By the way, this is our wish. So that's why we cannot declare this one also as a fully underfitting. The 77% is also high, it's acceptable. It is fine. Yeah, it's still okay. This 77% also is good. It's not bad. 95%. So it is when we start having like 100% here, and that is the one is going down, we can start maybe 45% or 50%, then we can start suspecting overfitting. 77 against 95. The idea of generalization is we always want to reduce the difference between this and this. We want to reduce it. So that is why you can see that 90, 91, this is perfect. Though very rare, in my experience with this kind of predictive solution, I think I've had it one time where I had 99% training and I got 100% testing. Only one time. So the data set was huge, like 48,000 samples. That was an Arabic character recognition. So, but it's a possibility. So what we have gotten is not out of place. And that's what we want. So a system that can train, got 90% of the training set and 91 on testing set. It means it doesn't memorize the training set. It's able to extrapolate better on the testing set compared to the training set on which it has been trained before. So yeah, this is a very unique outcome. So for sure, this is better. This is far better than this. Because if you get 95% in training, we don't celebrate it until we see the result of testing. Now testing performance has gone down. So that's why this one will be considered better than this one.
Okay.
Yeah.
Thank you very much, sir.
Yeah. Barakallahu Fi. Yeah. So, and that is why in some report or some research work, you might notice that no one is going to show you the training performance. They just show you only the testing performance. Even if you use Weka will only show you testing performance because this is the what matters actually. So for the training performance, people don't really care much, except when you want to calculate the time taken. And that's why in Weka, the default is to show you testing result only. Then you have to go and check it to show you the training result if you want to see it in the special, in the option for setting the outcome of the system.
Okay.
I hope that clarifies.
Thank you very much.
You're welcome. Barakallahu Fiik, Doctor. Mr. Salman or Dr. Salman, over to you.
Okay. Good morning, sir. Prof. Thank you for the presentation, sir.
You're welcome.
So, this is my question. I understand that in terms of building robotics and using robot to monitor to do some things, I understand that in that case, we are going to use reinforcement learning. But in other aspects, where we are going to employ the use of supervised learning or supervised learning, how can we detect from the data set, from this kind of data set, what kind of reinforcement are we going to use? What are the criteria we have to look for? So what are the things we have to look for in this case, in this crop monitoring system?
Okay. You mean you mentioned reinforcement learning, you mean for robotics?
No, I understand that, the use case for robotics, that was very clear.
Okay.
But I understand in the area where we are going to use reinforcement learning, we are going to use robotic. But in case there are some areas where we are going to use, because this kind of this thing you've presented is a very good topic. We are to achieve it. One cannot use just only one aspect of machine learning to do it. So a lot of machine learning model will be bring into place. But to determine where to use reinforcement, the supervised learning and not supervised learning. For supervised learning, you need to for the data has to be properly labeled. You have to label data.
Okay.
For supervised, you are going to use unlabeled data. So how can we? How do we determine in this case what kind of? You understand?
Thank you very much. Thank you very much. Yeah. So in that scenario, the first thing is to look at the challenge, like I mentioned at the beginning, is the lack of data set. These data set, they are supposed to be available, but people don't pay attention to it. You see, for example, when there was a problem on the farm, we just cried, shouted, and then we forgot about it. Rather than shouting and crying, we are supposed to gather the data. So that's why awareness needs to be created. That all these kind of things, instead of shouting, let's gather the data. What went wrong? Like I gave an example last week, when there was hurricane in the past, a lot of people lost their lives, but then people went into research. What caused the hurricane that met us unaware? Then they found out that before the hurricane, a lot of activity were taking place on the sea, under the seabed, but no one knew when it was going on. There were earthquakes underneath, this and that. Then they have to deploy sensors to gather even the simplest of activity under the sea now. They monitor it. And then the machine learning check can quickly compare. Oh, the last time we have this kind of activity, that was a disaster. So that was why whenever they get to be hurricane now, there will be a lot that they can evacuate people away from those kind of high-risk areas. So in similar way, data availability is very, very important. However, the first thing is to get the data. I always mention that the preference of let the data speak will always prevail. Now, so when you get the data set, first time, we now look at, okay, what do we want to have? Crop monitoring is a very big issue. There are a lot of possibilities, a lot of things that are involved. What are we monitoring itself? What do we want to monitor? Is it the yield production? Is it the possibility of pest invasion? Is disease spreading out? Can we detect it preemptively? So when we have the data set, we have what are the attributes of the data set? Is this something that we can use predictive solution for? Supervised learning. Sometimes supervised learning might not be possible. Even sometimes it might be possible, but you are not getting reasonable results because the data set is mixed together. They are labeled data already. Then we will have to use presentation later on what are the general principles of letting the data speak. Let's say, for example, somebody supplied us with a data set that has been labeled as 1, 2, 1, 2, 1, 1. That is, it has class 1, class 2, class 1, class 2, with some attribute x1, x2, x3, and this is the y. This data will be provided for us. Then, let the data speak principle says, push it in, let's see what they can get. Then you get some result out, but it's not going the way you expected it. So that's why when you use let the data speak principle, you must be very open to a lot of options. Even though this data has been labeled before being handed over to us, it doesn't mean that the labeling are all correct. It doesn't mean the data is free of a noise. So in that case, I might decide to bring in clustering. Even though it is a labeled data with only 2 classes, I can decide to cluster it into 3. It's a smart way of detecting that something might be wrong with the data. So when I cluster the data into 3, out of 2,000 samples, I found out that I have like 800 samples here in one cluster, another 700 samples in another cluster, and there was 300 samples in a small cluster here. I can effectively remove this cluster. Because they told me there are 2 classes, but now I'm getting 3 classes. So this class could be removed. I call it these are outliers, or these are dirty samples or incorrect samples. Then I will now go back again and train and test my model with this 800 plus 700 And uniquely, I started getting 99% accuracy and precision in my testing set. And before I did this, we were struggling to get 40%. It means these bad data sets, they were the ones that were actually affecting our work. So we have to be open to a lot of options. So the fact that the data is labeled does not mean the data is correct. So the moment the data is not performing, let the data speak. Original data is saying, hey, we cannot understand what the data is containing. Then we might have to, even though it was originally labeled data, we turn it back to clustering problem, cluster it, and then the clustering will identify some data that is not supposed to be there. It means these 300 samples, they are neither here nor there. So they are not in either of the classes, but they have been labeled by error or whatever. This is how far sometimes we may have to use non-conventional ways of solving problems, because some people, the moment they see labeled data, they assume it is fine, and they struggle to make it work. It doesn't work. No. So that's why experience matter. We have to reach out to people who are more experienced in this area, and they can make suggestions on what we can do. Sometimes we may have to do balancing, but as natural as possible, we have to make our data to be. Now, then, based on the data that we get, different ideas might have to be used. Do we need to do data imbalancing, or we don't need to balance the data? And sometimes we might have to incorporate multi-stage system. So first of all, use clustering, like I just demonstrated now, use clustering to clean the data better, and then you move to classification. After classifying, then you move to regression, depending on the kind of outcome we have. So we have to be open to different types of machine learning techniques and algorithms that can work. And there's no one that you can guarantee that is going to work for you. So we have to check and try, and then keep trying. And then based on some of the principles we've covered and some of we're going to cover, I want to believe that we can be able to. And sometimes reinforcement learning also could be used in other areas, and also deep learning, and also further. We have to just keep the options open, because there's nobody that can tell us that this is the best method to use. If in machine learning, anybody that tells you this is the best method, no, he doesn't understand machine learning. There's no method that is best. It depends on the data set that you are using. So one algorithm is so powerful on a data set. The same, another data set comes in, this algorithm is failing. A very simple algorithm is performing. Always remember, keep it simple. Start from simple algorithm, then to more sophisticated or complicated algorithms. By so doing, because sometimes sophisticated algorithm might not be able to detect the hidden pattern in the data set, and then you miss the opportunity. So simple one would have detected it. We've had that before. People use deep learning. Meanwhile, ordinary k-nearest neighbor was getting 98. Deep learning was getting 75. It happens. So we have to be able to start simple, then gradually go into more sophisticated algorithm, depending on the problem we are solving. And then we have to be open to several options and ideas on how to keep the work going towards achieving better result. Most especially in what I refer to as proactive. So proactive crop monitoring, so that we want to identify problem, disease, pest, possibility of outbreak before they actually come up. By so doing, we can put in preventive control to achieve our aim. I hope that clarifies the question.
Yes, sir. Yes, sir. Thank you very much, sir.
You're welcome. Thank you very much. So, Dr. Hamzat Abdullah Hamid, second. You can unmute yourself.
Yeah, thank you very much.
You're welcome. We can't hear you again. Can you?
Oh, sorry.
Yeah.
Thank you. Your last statement before the end of the class,
yeah.
You made mention that we can check the the training performance on Weka. Can you please demonstrate it? How we can do that?
How you can check the training performance?
Yes, on Weka.
Okay. Okay. Okay, let me check. I'm not sure if I have. Let me check.
If you don't have it today,
let me see. I will check if I have Wika. Hopefully, open on my system.
Okay.
I'll show us how you can check it there. Is that that's your question, eh?
Yes, sir. Yes, sir.
Okay. Thank you very much. So we come back to that. So
Okay,
yeah, okay. The question also is how the training performance can be checked in Wika. That's fine. Yeah, there's a question. In the case where only one or two algorithms are selectable to use in Wika, while others remain blurred, please, what could be the cause and possible remedy? Okay, in Wika has the way of detecting that your problem is either classification or regression problem, especially the last data in the extreme right of your CSV file that you uploaded to Wika. So that is the column that is assumed to be the predictive, the target. So you have to make sure that your target is in the last one. This is by default. But if you don't want it to be the target, then immediately you upload your data, you have to change it there. There's a way to change that. Oh, my target is this. So, but people upload it and they forget. So you might end up predicting wrong value. So that's why I usually tell people that the best way is to make sure that the last column in your Excel file is the output. So by so doing, you will not forget, because if you say, okay, whenever I upload my data, I will tell the Wika which one is my input, it's my output. You might forget sometime. I've seen someone spend a lot of weeks running experiment, plotting. It was actually plotting wrong values because it was predicting a wrong variable. So we have to pay attention to this. So the moment you upload your data set, Wika will detect that last column as your target. So if that last column is number, for example, you are solving a classification problem and you have 1, 2, 1, 2, 1, 2, that means class 1, class 2, but that one is written in number. See, it's written in number. 1, 2. Anything in number, Wika takes it that this is a regression problem. You get the point now. So it will activate only algorithms that work on regression, even though you want to solve classification problem. These are problem. This is one of the very common problems why people have this kind of thing. It only activates those that can work on regression only. However, what you have to do is you have to take back your file. 1 needs to be changed to maybe Y, and 2 needs to be changed to no, N, no. You can write it in full, yes, no. You can write it in full, sick, healthy, depending on the class. This is very important. So this could be one of the cause why you see a lot of algorithms that are gray out. So go and check your output to make sure that what is in the last column that is taken automatically as output is something that can be solved using the regression you are targeting or the classification, as the case may be. So if your data came with 1, 2, and it is classification, first thing you have to do pre-processing by changing that 1 to yes and 2 to no, or healthy patient, sick patient, depending on the problem you are solving. So I want to believe when you do that, if you do that, then that problem should be solved, hopefully. So, and I want to believe also we can check out how to run your first machine learning experiment in Wika in our YouTube channel. I believe it also describes some of these pre-processing that are very important for us to do to avoid getting error messages when we start running the experiment. So, can we see the Wika screen now? Hello?
Yes, doctor. Yes, doctor.
Yes.
Yeah. See, this is what I was talking about. See, this is the target. Whenever you load your data, the last column in your Excel, number 14 now, is taken automatically as the target. So that's why you have to make sure you have your data. You can see here this yes or no. So this is very important. Very, very important. So otherwise, you might be having wrong prediction, which unfortunately you will not realize it. The result will be always wrong. So, but here, for the questioner who said, if you want to, like when you run the experiment like this, This is 100% classification result outcome. So the result here, that the result of testing set. Training set are not shown usually. So if you want to see the training result, then you have to go back to these more options. You go inside these more options. Then therein, you can say, can you see here? You can see that this was not checked. Output models for training splits. I want to see the result of training. It's not unchecked. By default, it's not shown. So you have to check it. Now your training result will be out. So you are going to have so many results. After training result, then the next you are going to have the testing result. So this is how you are going to check your training result. By default, it is unchecked. So you have to check it to be able to see it. And then you are going to, if you want to even see the entropy evaluation measures, other details, error plotting, whatever you want to see, output, I want the prediction to be shown. Another thing also, you want the prediction to be shown. I want it to be in plain text. You select it there. Then you can see it. Then you can build the next model, a new model built now. Everything will now be displayed in more detail compared to the one you built earlier. I believe that was the question asked by the questioner. Hope that is clear.
Yes, doctor. Thank you very much.
Okay, thank you very much. Yeah. Finally, regarding what I was explaining, that once you load your data, this is taken as the target automatically. The last column in the Excel, you uploaded CSV file. But here you can change it here. You can see here, this is the target, what I want to predict. So I can decide to say, I'm not predicting this one as target. I want to predict the gender. Gender is my target now. So I've changed it. So because some people, when they upload the data, they don't care where the position is. Even if the target is the first column, they will come here and change it. This is very important. But the problem is sometimes once you upload your data, you forget to do that. And if you forget to do that, it will take the last column as the original target. So this is why I always tell people that, though not compulsory, but to be on the safer side, always let your last column be the target value that you want to estimate, or you want to classify, or you want to predict. But if you don't do that, always remember that here you have to set what is the target that you want to estimate. Otherwise, you'll be wasting your time thinking you are doing the right modeling. Meanwhile, you are doing it on the wrong attribute. So thank you very much.